Hey guys, it's Miss Adams, and we're going to be looking at the Unit 2 portion of the Algebra 1 midterm review. So this video is just going to walk you through all the questions from the Unit 2 portion of the midterm review. So let's go ahead and get into it. It says for question 10, the length of a rectangle is 4 centimeters more than the width. The perimeter is 72 centimeters. Write the equation that models this. And then it says what are the dimensions of the rectangle. So it says to draw a picture, which may help you out greatly. It also said we have two things that we need to do too. Write the equation and then find the dimensions of the rectangle. So let's start off just by drawing out a rectangle. Now, we know that our length, which I'm going to call L, is 4 centimeters more than our width, which is what I'm going to call W. So, if I'm looking at this, we have our widths on the side, and then our length can be written in terms of our width. We can say that our length is 4 plus our width. So now we've got two lengths, we've got two widths, and we can solve for the perimeter. The equation for the perimeter of a rectangle is P equals 2 times the length plus 2 times the width. So, let's find the perimeter of this rectangle. So P is going to equal 2 times my length, which is 4 plus W, plus 2 times my width. And it's asking us to write the equation that models this. So this is an equation, but we want to write it in its simplest form. So we're going to have to use the distributive property. Excuse me there. So for each of these parentheses, we have a 2 on the outside, so I'm going to do 2 times 4 and 2 times W. And for the second term, it's just 2W. So we're going to have P equals 2 times 4, which is 8, plus 2W. Plus 2W again. And now we combine like terms. We have 2W plus 2W. So this means the equation for our perimeter is 8 plus 4W. So that's the first step that it's asked us to. Well, we've drawn our picture and now we've written the equation that models this rectangle. Now, we have to use the perimeter is 72 centimeters. So it tells us that the perimeter is 72 centimeters. We're going to use this to find the dimensions, so our width and our length of our perimeter. So where it says perimeter, I'm going to replace that with 72 centimeters. And that's going to be equal to 8 plus 4W. And now here's where the math comes in. We're going to subtract 8 from both sides. So we have 72 minus 8. That's going to give us, let's see here, that's going to give us 64 equals 4W. And then we're going to do 64 divided by 4 to isolate our variable W. So we're going to divide both sides by 4. So our width is going to be equal to 16 centimeters. So we know our width. Now we've got to find our length. Well, I know that my length is equal to 4 plus my width. So, my length is going to equal 4 plus 16. So the length for this perimeter is going to equal 20 centimeters. So now we have finished that problem. We've found the equation and we found our dimensions of the rectangle. Let's go on to problem 13. It says the sum, so I know I'm going to need that, the sum of 7 and 2 times the number is 15. Determine the number. So it wants us to read that backwards. So I've got the sum of 7, so I'm going to need 7, and then 2 times the number is, so this is important, is 15. Sum is addition. 2 times means I'm going to multiply by 2. And is means it's equal to 15. So I'm going to have 7 plus 2 times some number is equal to 15. and it's asking us to determine the number. So it's actually asking us to solve this value. So I'm going to subtract 7 from both sides. So 2n is going to be equal to 8, because 15 minus 7 is going to give me 8. Divide by 2 on both sides. So our number is then 4. Alright guys, and that covers problem 13. So let's go on to problem 14. We've skipped 11 and 12 somehow there. You know, math teachers, sometimes we miss numbers. It's all good. Alright, so number 14 says fill in each table by solving for x and stating the properties. So this is where our properties of equality come in. Remember, that means what we do to one side, we must do to the other side. So your first reason is always going to be given, because we are given this equation, 2 times x plus 1 is equal to 7. Well, our next step is to do the distributive property, which you do not have to show the work on this on your statements. Your statement should just be what you would do after you do the math. So when I distribute that, I'll have 2x plus 2 is equal to 7. And because we did not distribute on both sides of the equation sign, this is not going to be a property of equality, but you just call this the distributive property. If you want to get real technical, you could say the distributive property of multiplication. Now, this is when our properties of equality come in. We want to isolate our variable term in order to eventually isolate our variable, or to solve for our variable. So our first step to get our variable term by itself is I'm going to have to subtract a 2 from each side. And once again, guys, you do not have to show your work on this. Your statement should just show those blanket statements. So I'm going to have 2x is equal to 5. And that's going to be due to the subtraction property of equality. We're almost there. We've isolated our variable term. Now we have to isolate our variable. And in order to do this, we're going to have to use our division property of equality. So we're going to divide both sides by 2. So our final statement should be x equals 5 halves. Or you could write this in decimal form to where it equals 2.5. So this is due to our division property of equality. So now let's go on to problem 15. It's asking us to draw all 3 possible solutions of a system of equations, then state how many solutions for each. So the first one we talk about is one solution. This is where they have one intersection point. So remember, when you're looking at a system for a solution for a system of equations, this is where they intersect. So the most common one that we've seen in this class is where 2 lines intersect at one single point. This means it has one solution. Then we had some that were all solutions, so an infinite amount of solutions. This is where both of our lines were the same line. Now, don't judge Miss Adams' drawing. I'm not the perfect drawer ever. But looking at that, we see that the lines overlap. That means every single solution is going to be true for both of these equations. So this is going to be infinite solutions. And it's because they are the same equation. They just may be written a little different. Maybe one has a common multiple of 2, or a common factor of 2 in each of the terms. Maybe it's that they're just in different formats. One is in standard form, while another is in slope-intercept form. But they're going to be the same equation either way. Then lastly, we're going to have no solution. And these are parallel lines, guys. So they're never going to intersect. Parallel lines, no solution. Let's move on to problem 16. It says to graph the system, then identify the solution. Luckily for us, these are already set up into slope-intercept form. If they weren't in slope-intercept form, we would want to convert them to slope-intercept form before graphing. So let's look at our first line. It says y equals negative 3x plus 5. That means our y-intercept is at 5, and our slope is negative 3, which means we're going to go down 3 to the right 1. Or we can go up 3 and to the left 1. And because these are equations, it's just one solid line for that equation, and we can move on to the next. We have y equals 2x minus 5. Our y-intercept is at negative 5. And our slope is positive 2, which means we're going to go up 2 to the right 1. Or we could go down 2 and to the left 1. And connect the dots. Remember to draw your arrows as well, because these are equations, they're going to be continuous. They're going to continue on from negative infinity to positive infinity in both the x and y axes forever. So now we're going to look for our solution. The solution is where they intersect, and we have an intersection point here at 2, negative 1. So where x is 2 and where y is negative 1. That's how we solve a system graphically. Now for problems 17 and 18, we're going to solve a system algebraically. So this first one says to solve by elimination. That means we're literally going to figure out a way to eliminate one of our variables. If I'm looking at the equations, I have 5 plus y equals negative 1 and x minus 2y equals negative 9. Well, we don't have any common coefficients on our terms, and we don't have opposite coefficients either. So we're going to need to multiply one of our equations so that we have opposite coefficients so that one of our variables can be eliminated, or we can take away one of our variables. So let's see here. On the second one, I have x minus 2y equals negative 9. Because the y is already negative, we can actually multiply that first equation by 2. I'm going to have to distribute the 2 to every term in the equation, giving us 10x plus 2y equals negative 2. Now looking at this, if I'm looking at my two equations, I've got x minus 2y equals negative 9, then 10x plus 2y equals negative 2. Our y's have opposite coefficients that when they add together, they will be eliminated. So let's add the two equations together. X plus 10x is 11x. Negative 2y plus 2y eliminates. Then negative 9 plus negative 2 is going to give me negative 11. I can now divide by 11 on both sides and solve for my variable x, which is going to be that x equals negative 1. Now that I know that x equals negative 1, I can input this into either of the first two equations to solve for y. So I'm going to substitute my value of x, so 5 times negative 1 plus y equals negative 1. 5 times negative 1 is negative 5 plus y equals negative 1. And I can add 5 to both sides to get me to where y equals positive 4. And we have found our solution for this system of equations to be negative 1, 4. So that's solving by elimination. Now let's solve by substitution. So I have the two equations, 2x minus 3y equals 16 and x equals 3y plus 2. Because our x variable is already isolated in our second equation, we can use this equation and substitute its value into x in the first equation. So I can say that 2 times 3y plus 2 minus 3y is equal to 16. And I can use the distributive property to say that 6y plus 4 minus 3y equals 16. Looking at this, I have common terms on one side of the equation. So I can combine 6y and negative 3y, or 6y minus 3y. That's going to give me 3y plus 4 is equal to 16. I'm going to subtract a 4 from both sides. So 3y is equal to 12. And because this is an equation, I'm going to use the division property of equality, divide both sides by 3 to isolate my y, and to get that y equals 4. I can now use this y equals 4 in any equation. I'm going to choose the second equation since it's already solved for x, and to solve now for the variable x. So I'm going to substitute that y value into the second equation. So I'm going to have x equals 3 times my y value of 4 plus 2. X equals 12 plus 2. So x equals 14. So my final solution is 14, 4 for the intersection point of this system of equations. Now let's go on to problems 21, 22, and 23. So we're taking some numbers out here. We're actually going to manipulate these variable equations to solve for the indicated variable. So 21 says r plus b divided by v is equal to w, and it wants us to solve for the variable b. So we're trying to solve for this variable b. First thing we're going to have to do to both sides is multiply by v. We want to get that v out of our denominator. So now I'm going to have r plus b is equal to wv. And now we just have to do the opposite operation, because currently r is being added to b, and to take away r from b, I'm going to have to subtract. So I'm going to subtract r from both sides. So isolating my variable b, I'm going to have the equation b equals wv minus r. Let's move on to problem 22. It says f equals gk plus q, and it's asking us to solve for the variable k. So first thing I'm going to have to do is to isolate that variable term. So I'm going to subtract a q from both sides. So I have f minus q is equal to gk. Currently g is being multiplied to k, so I have to do my opposite operation. So I'm going to divide both sides by g. To get k isolated by itself in the final equation, k equals f minus q divided by g. Now let's look at this last one. It says to solve for the variable m. Right now I have dmx is equal to b, and I'm solving for m. Well, currently m is being multiplied by both d and x, so all I have to do is divide both sides by d and x. So m will be equal to b divided by dx. Let's go on to problem 19. So I apologize for some of these being out of order. We're working on our math skills, guys, as Algebra 1 teachers. We're doing what we can. Alright, so number 19 says, Mr. Roper is taking your class on a field trip to the Holocaust Museum that charges $4 for adults and $2 for students. A total of 27 tickets were purchased for the field trip at a cost of $60. How many adult tickets and how many student tickets were purchased? So the first thing I have to look at is, what are my two variables? What are my two unknowns? Well, we have adults and we have students. So let's set our variables for our adults and our students. I'm going to say that A is equal to the number of adults, and that S is equal to our number of students. So we're given two totals here. We're given the total number of tickets, and we're also given a total cost of $60. So that means our two equations are going to deal with the number of tickets. So we're going to have one equation with the number of tickets, and one equation with the total cost. So let's look at that. It tells us that a total of 27 tickets were purchased, which means I'm going to just add up my number of adult and student tickets. So A plus S is equal to 27, because we don't know how many of each ticket were purchased yet, but we can do that by solving our system of equations. We know that each adult ticket costs $4 and each student ticket costs $2, and we know that they spent a total of $60. So for each adult ticket, they paid $4, and for each student ticket, they paid $2. So 4A plus 2S is equal to 60. Now we can either solve this by substitution or elimination. It is your choice. I'm going to show you by elimination. So I have A plus S equals 27, and 4A plus 2S is equal to 60. Now, it doesn't matter which variable you choose to eliminate, as long as you just choose one. It's going to be easiest for us to multiply our first equation by some number in order to allow the elimination to occur. So let's eliminate our S variable. I want it to have the opposite coefficient than 2, so that means I'm going to multiply this first equation by negative 2. And that's going to give me negative 2A minus 2S is equal to negative 54. Now, I can look at these two equations and add them together. When I do so, I'm going to get that 2A. So 4A plus negative 2A is 2A. My S's are going to cancel out because 2S plus negative 2S eliminates, is equal to 60 plus negative 54, which is going to give me 6. Now I solve for A. Divide both sides by 2. So A is going to equal 3. So I know there are 3 adult tickets. Now we have to find the number of student tickets. So let's go ahead and substitute 3 into this first equation for our A to solve for S. So I'm going to say 3 plus S equals 27. Subtract 3 on both sides. So S is equal to 24. So therefore we have 3 adult tickets and 24 student tickets. Now let's move on to problem 20. Now we're getting into inequalities. So we've talked about just equations. We're going to switch over to inequalities. So it says, for what values of x is the inequality true? And we're given 4/7 minus x over 7 is less than 1. If you're like me, I don't enjoy fractions, and they both have the same denominator, which means I can multiply that whole equation by whatever the denominator is. In this case, it's 7. When I do that, and I distribute the 7 to every term, it's going to eliminate my denominators in my fractions. So I'm going to have 4 minus x is less than 7. Now I can go about solving this like I would an equation, except there's an inequality sign there. So I'm going to subtract 4 from both sides. That's going to give me that negative x is less than 3. But I want to solve for just x, not negative x. So I'm going to need to divide both sides by negative 1. And with inequalities, if you divide by a negative number, you're going to have to flip the inequality. So x is going to be greater than negative 3. Alright, let's go to the second inequality here. So it says solve the inequality, then graph your answer on the number line. Let's isolate our variable term first by subtracting 7. So I'm going to have negative 5m is greater than negative 15. Then we're going to have to divide both sides by negative 5. And once again, if you divide by a negative, you have to flip your inequality. So m is going to be less than 3. And if we put that on our number line, let's say negative 2, negative 1, 0, 1, 2, 3, 4. It's going to be an open circle at 3 because it doesn't equal it. And so it's going to be everything less than 3. So pointing towards the left. Alright guys, let's go on to problem 22. It says to graph the system of inequalities, then identify a solution and a not solution. So when we graph a system of inequalities, we're going to find the shaded region that is true for both of these inequalities. So let's look at the first one. Is y is greater than negative 1/2 x plus 2. So our y-intercept's at positive 2. Our slope is negative 1/2, so down 1 to the right 2. Or you can go up 1 to the left 2. And this is greater than, so it's going to be a dashed or dotted line. So I'm pretty much just going to keep it the way I have it. And I'm going to be looking at everything greater than that line, but I don't want to shade it yet. I want to go ahead and graph my other line. I've got y is less than or equal to 3x minus 1. So I'm going to find where negative 1 is on my graph. That's my y-intercept. And my slope is positive 3. So I'm going to go up 3 to the right 1. Or I could go down 3 to the left 1. And because this is less than or equal to, it is going to be a solid line. Now I want to find the shaded region that is below my blue line, but above my red line. So it's going to be right about here. And it says to identify a solution and a not solution. Well, the solution is going to be any point that is in that region. So let's say that we choose the point 4, 4. That can be a solution. And a not solution is any point that's not in that shaded region. So let's say I choose the point negative 8, negative 4. Let's continue on. Let's look at problems 23 and 24 real quick. It says the graphs below show the relationship between x and y. Write the inequality in slope-intercept form that describes each graph and then states if the points are solutions. So first thing we have to identify is where's our y-intercept. In this case, our y-intercept is at 3, and then our slope is up 2 to the right 1. So I know my y-intercept is at 3. My slope is 2 over 1, which is just 2. And this is a solid line shaded below. So it's going to be y is less than or equal to our slope, which is 2, times x, plus our y-intercept, which is 3. So that's the equation for this graph of 23. Now it's asking us if the point 2, 1 is the solution. Well, right 2, up 1. That's in our shaded region, so it is a solution. And now it's asking about the point negative 1, 1. So I'm going to go left 1 and up 1. This lies on our line, but because it's a solid line, this also is a solution. Let's look at number 24. Y-intercept is at negative 2, and our slope is going to go up 2 to the right 1, 2, 3. So I know I'm going to have 2/3 x minus 2. And it is a dashed line shaded above, so y is going to be greater than 2/3 x minus 2. Let's look at this first point, 1, negative 1. If I go right 1, down 1, is this in my shaded region? It is. It doesn't lie on the line, so this is a solution. Now let's look at the point 3, negative 2. So if I'm going to find 3, negative 2, I'm going to go right 3, 1, 2, 3, down 2, 1, 2. This lies outside of our shaded region, so it is not a solution. Let's look at problem 25. It says to rewrite this in slope-intercept form. Just like we have been doing, guys, we're going to isolate our y. So we're going to subtract 3x from both sides to start off with. So I'm going to have negative 5y is less than or equal to negative 3x plus 10. And I now have to divide everything by negative 5. When you divide an inequality by a negative number, it is going to flip. So y is going to be greater than or equal to 3/5 x minus 2. Let's move on to problem 26. It says to determine whether the following points are a solution of the inequality, 10x plus 18y is less than or equal to 10. So I'm going to input the value of these of each point into this inequality. So I'm going to say 10 times 8 plus 18 times negative 12 is less than or equal to 20. So when you use your calculator, you're going to have 80 minus 216 is less than or equal to 20. So that means negative 136 is less than or equal to 20, which is a true solution because negative 136 is a lot less than 20. Let's look at the next one. It says 10, substitute the value 6 in for x, plus 18, substitute the value negative 3 in for y, less than or equal to 20. So that's going to be 60 minus 54 is less than or equal to 20. So that says 6 is less than or equal to 20, which again is true. This is a true statement because 6 is less than or equal to 20. And our last one gives us 10 times negative 4 plus 18 times positive 4 is less than or equal to 20. So that's going to give me negative 40 plus 72 is less than or equal to 20. That says 32 is less than or equal to 20, which is not true. So this is not a solution. Last question here for Unit 2. It says, what is the difference between an equation and an inequality? An equation has one solution, while an inequality has many solutions. It is a range of solutions. Alright guys, let us know if you have any questions over Unit 2.